To determine if data are distributed normally, we need to look at two things. First, is the distribution symmetric? And second, do the data follow the 68-95-99-7 rule? In order to do this, we need to construct a special histogram. And this histogram is centered around the mean and the standard deviation of the data. So if we take these 25 possible test scores and find their mean and standard deviation, we can construct this special histogram. So let's take out our calculators. If we turn our calculators on and hit Stat and then Edit, we can enter the data into List 1. Once we've entered the data, we can select Stat again, move over to Calc, and select one of our stats and hit Enter, and we get our X-bar and standard deviation. The next thing we're going to do is set up the x-axis of our histogram. And again, we're going to center it around X-bar, which is 79.9, subtract the standard deviation, subtract it again, and subtract it a third time. And then we're going to add it again, and add it a third time to find all of our axes markings. Next, we're going to go back to the calculator and set up the window of our histogram. So we're going to hit second y equals, hit Enter, make sure we're talking about a histogram showing list 1. And then we're going to select the window, and our x minimum, we're going to go into vars and then statistics and then find x-bar. Because for our x minimum, we're going to take x-bar and then subtract 3 standard deviations. Again, we're going to go into vars, statistics, to find SX, and then hit Enter, and it's going to calculate our minimum. We're going to do the same thing for the maximum, but it's going to be x-bar plus 3 standard deviations. Now, do you need to enter the equation every time? And the answer is no. If you've already calculated the value for xmin and xmax, like we already did on the paper, you could just type in the values. Now for x scale, that's the bin width, and the bin width for this whole thing is 1 standard deviation. And then for y max, just try to guess how tall do you think the tallest bar is going to be. And I just guessed 10, and I got it right. Alright, so now we're going to trace our bars, and we see that the first bar had 0 values, and then we see what the rest are. And then we're going to write this down on our piece of paper. The reason we're going to do this is we need to draw out the histogram, and then we're going to check the 68-95-99-7 rule, which has to do with how many data points lie within 1 standard deviation, 2 standard deviations, and 3 standard deviations. So let's first check how many lie within 1 standard deviation. As you can see, there are 8 data points to the left of the mean and 9 to the right that are within 1 standard deviation. So we add this, get 17, divide by the total number of data points, and we get 68%. Within 2 standard deviations, we just add the values in the next 2 bars. So 4 plus 8 plus 9 plus 4 is 25, which is 100% of the data, which then makes sense that it's also 100% within 3 standard deviations because those outermost bars have no additional data in them. So now, how does this compare to the 68-95-99-7 rule? Well, so long as your percentages are within about 5 percentage points, then we can say that yes, it follows the 68-95-99-7 rule. And then by looking at the distribution, we can see that yes, it's pretty symmetric. So based on these 2 criteria, we can make the conclusion that yes, these data are distributed normally.